Hello Worthington Juniors, here to learn all about trigonometry, and I'm here to teach you about trigonometry. When we talk about the idea of trigonometry, of trigonometric ratios, what we're really talking about is the ratio, or fraction, of two side lengths of a right triangle. We're going to talk about three of the basic trigonometric functions today, and those are sine, cosine, and tangent. And they do have abbreviations that are used all the time. SIN for sine, COS for cosine, and TAN for tangent. So you're going to see me use those abbreviations for sine, cosine, and tangent functions. Here we go, let's jump right in. How do we find these ratios? Well, as long as we have a right triangle, all the time when you use these trigonometric functions, you need to have this right triangle in order to set up these ratios. Okay, as long as we have that right triangle, the sine, cosine, and tangent of some acute angle are defined as the following. The sine of an acute angle is going to be the opposite side over the hypotenuse. The cosine of an acute angle is going to be the adjacent side to that angle over the hypotenuse. And the tangent is going to be the opposite over the adjacent. Now let's talk about these for just a moment. If we're looking at angle A, opposite means not touching, across from. So this would be opposite. Adjacent means touching, but is not the hypotenuse. The hypotenuse is the one always across from the right angle. The hypotenuse will never change. When you're given a right triangle, you should automatically be able to point out which one is the hypotenuse. Once you've located the hypotenuse, the other side touching that angle is the adjacent. And the one opposite is, well, the opposite. Now, you're going to have to remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Best way to do that is to remember the term SohCahToa. S-O-H-C-A-H-T-O-A. SohCahToa. It helps you to remember. Let's look through this. It tells me that the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. SohCahToa. Sine, cosine, and tangent. And tells you what those ratios are. Alright. Here we go. Find the sine, cosine, and tangent for the indicated angle. So in a right triangle, you actually have two acute angles that you could be finding these trigonometric ratios for. So if we're asked to find sine, cosine, and tangent of both of those, let's see how they differ. Let's start with the sine of D. If we're looking at angle D, here's angle D. Sine, if you remember, we have SohCahToa. Sine is the opposite over the hypotenuse. So if we're looking at angle D, what is opposite? 14. Hypotenuse? Hypotenuse is always going to be the 50. So opposite of D and the hypotenuse is going to be 14 over 50. So the sine of D is 14 over 50, or simply 7 over 25. You can reduce, never a problem to reduce. Now, cosine of D, so we're still looking at angle D. The cosine is the adjacent over the hypotenuse. So adjacent is the side that is touching. So we're looking at 48 over the hypotenuse. Hypotenuse is always 50. So the cosine of D is actually 48 over 50, or we can reduce to 24 over 25. Lastly, tangent of D. Here's angle D. Again, tangent is opposite over adjacent. So we're looking for the opposite side and the adjacent side. So the tangent of D is 14 over 48, or 7 over 24. Great. Now, what happens if I change to angle E? Well, what you should notice is that the hypotenuse is still 50. However, this time the opposite of E is going to be 48 and the adjacent to E is going to be 14. So our opposites and our adjacents have switched roles. So our sine, cosine, and tangent are going to be a little bit different. The sine of E is still the opposite over the hypotenuse, just this time, what is opposite of E? Well, 48. So we're going to have 48 over 50. Or again, we can reduce to 24 over 25. Cosine of E. Cosine is the adjacent over the hypotenuse. We're going to take our adjacent over our hypotenuse, and we're going to have 14 over 50, which is going to reduce to that 7 over 25 again. Tangent of E. Tangent is opposite over adjacent. So if we start at E, what is opposite? 48. What is adjacent? 14. So we're going to take opposite over adjacent, 48 over 14, which reduces to 24 over 7. So that is just the basic idea of how to pull out some of those trigonometric ratios from some right triangle picture. So you need to keep in mind which angle we're looking for, because it does make a difference as to which one is the adjacent and which one is the opposite. Okay, let's talk about something else. First of all, you are going to have to be able to plug in degrees into the sine, cosine, and tangent functions sometimes. We always have some angle. And when we plug those into our calculator, it's actually not too hard. There are buttons on our calculator that are simply sine, cosine, and tangent. The issue is making sure our calculator is in the right mode. Now, what I mean by that is if we look at my calculator here, if I click on the mode button, if you have one of these bigger calculators, click on the mode button. Notice there is a radian and a degree. Mine is darkened on degrees. If yours is not, you need to arrow down, go over to degree and hit enter so it's darkened on degrees. Once you've done that, your calculator is in degrees and you should be fine to type in these things. So if I wanted to type in the sine of 82, I could simply do that. I just type in the sine of 82 and I get the right answer of about 0.9903 if we round. And if we double check with our calculator, you should find that when you type it in, if you're in the correct mode, the cosine of 82 degrees is approximately 0.1392 and the tangent of 82 degrees is approximately 7.1154. So just making sure our calculator is in the correct mode. If you're not sure how to do that on your calculator, feel free to come in anytime and see any of your math teachers and we'd be happy to help you do that, making sure you're in the right mode before the test. Next, we use these trigonometric ratios to help solve triangles, whether that's in word problems or just like these, just some figures thrown out here and we're asked to find the value of the variables. Now, here we go. Let's jump in. Let's just try finding x. How do I find x? Well, we have to look at our given information. We are given a side length of 3 and we are given a 72-degree angle. With this given angle, we know the adjacent. Let me go ahead and write this on the board again in case you don't remember. SohCahToa. We are given the adjacent to that angle. If we look at simply x, x is the opposite. So I'm going to take it one variable at a time. I'm going to focus on just the x right now. X is opposite of the given angle and we know the adjacent. Well, what trig ratio would relate these two? So if we look, we're looking for something that would relate opposite and adjacent. And we should find that to be the tangent. So what we should have is that the tangent of 72 degrees equals the opposite over the adjacent, and that is x over 3. So the tangent of 72 degrees equals the opposite over the adjacent, or x over 3. Now, what do we have to do? We have to solve this, and to solve it, I think of it as a proportion. So if I put this over 1, to solve, I'm going to cross multiply. So I'm going to take the tangent of 72 times 3 and 1 times x. So my next step is that 3 times the tangent of 72 degrees equals x from cross multiplying. Well, x is all by itself. So now you get to just type this in your calculator. Take 3 times the tangent of 72 degrees and you should find x to be approximately 9.233. Important thing to remember, when you take 3 times the tangent of 72, the tangent of 72 is one term all by itself. Don't try multiplying that 3 onto the 72. Leave it out front. Always put it out front. Okay, now let's move on to the y variable. For this picture, the y is the hypotenuse. So if we go back, let's forget about our x for the moment. Our given information is our given acute angle of 72 degrees and its adjacent side of 3, and to solve for y, we're looking for the hypotenuse. So we're going to be looking for a trig ratio that relates the adjacent and the hypotenuse. And what relates the adjacent and the hypotenuse? That's the cosine. So we want to say that the cosine of 72 degrees equals the adjacent over the hypotenuse, or 3 over y. And that's exactly where we're going to start. The cosine of 72 degrees equals 3 over y. Again, to solve this, we're going to put the cosine over 1, and we're going to cross multiply. So we're going to end up with y times the cosine of 72 equals, well, 1 times 3, which is 3. Now this time we're not done. We don't have the variable by itself. What's happening is the y is being multiplied to the cosine of 72. To undo that, we need to divide both sides by the cosine of 72, which is going to end up with us being left with the equation y equals 3 over the cosine of 72. Now we have y by itself, and we have all this numerical stuff on the right-hand side. We get to just type this in our calculator. So if you take your calculator, making sure you're in degrees, and you take 3 divided by the cosine of 72, you should get approximately 9.708 with rounding. Okay. Good. Hopefully that went well. Let's try the next triangle. Again, we have an x and a y we need to solve for. We need to stop and evaluate what our given information is. So, here is the given acute angle. And we're also given 12. How is 12 related? Some of you might be thinking it's adjacent, but that's not correct because it is not specific enough. Notice your right angle, and that 12 is across from your right angle, which means if you're being as specific as possible, this is the hypotenuse and will always be the hypotenuse and should only be thought of as the hypotenuse. So we are given the hypotenuse with this acute angle, and if we start with the variable x, this time we're looking for the adjacent. So looking for the adjacent when given the hypotenuse, what is going to relate these two things? Adjacent, hypotenuse, that would be cosine. So I'm going to start my equation by saying the cosine of 63 degrees equals the adjacent over the hypotenuse, or the cosine of 63 equals x over 12. Now, how do we solve? Well, cross multiply, just like last time. So we're going to take cosine of 63 times 12, or remember, put that 12 up front. 12 times the cosine of 63 equals x times 1, which is x. Now we have the variable by itself, and we simply get to type that in your calculator. If we take 12 times the cosine of 63 degrees when in the right mode, we'll get x is approximately 5.448. Okay, let's look at our variable y. Y is opposite our given angle. So this time, solving for y, we're looking for the opposite, and we know the hypotenuse. So opposite and hypotenuse is our sine function, our sine trig ratio. So we're going to set up the sine of 63 equals the opposite over the hypotenuse, or the sine of 63 equals y over 12. And once we have the sine of 63 equals y over 12, we can cross multiply. And again, we get 12 times the sine of 63 equals y. At this point, the variable is all by itself. We get to type it in our calculator, and we end up with approximately 10.692. Now, I round to 3 decimal places approximately. Your test may ask you to leave it exact. You might see this number written as your option. They might round it to the nearest whole number, so they'd round to 11, or the nearest tenth. If they round to the nearest tenth, this would be 10.7. Don't forget about your rounding when looking at your answers. Okay, let's try a couple of word problems. First word problem is, if you are measuring the height of a building and you stand 100 feet from the base of the building and you measure the angle of elevation from a point on the ground to the top of the building to be 48 degrees, estimate the height of the building. Best thing you can do, if you're not given a picture, draw a picture. Here's our building. Yes, this is a building. Look at pretty pictures. Okay, you are standing 100 feet from the building. This is you. This is 100 feet. No, this is not to scale, but it's a good approximation. And as you look up to the building, so your angle of elevation to the top of the building is 48 degrees. It wants to know, what is the height of the building? Now, if this is a good building, as it should be, the building and the ground make a right angle. So we actually have a right triangle with a given angle. So we have this triangle. the acute angle of 48. This side is 100, and we're looking for this unknown side. With the given angle measure, 100 is actually the adjacent, and h is the opposite. Now, if we want to relate the adjacent and the opposite together, we're going to need to use tangent, because the tangent is the opposite over the adjacent. So that's how we're going to set up this problem to solve it. We're going to say that the tangent of 48 degrees equals h over 100. So to solve, same situation as before. Put the tangent of 48 over 1 and cross multiply. So we're going to get 100 times the tangent of 48 equaling 1 times h, which is h. And, well, we're good to go. Let's type this in our calculator. That's the exact answer. The approximate answer would be 111.06, or if you're asked to round to the nearest foot, we could say the height is approximately 111 feet. Okay, hopefully that went well. Let's try it. One more word problem. Here we go. A driveway rises 12